Good day, everyone. Welcome to our presentation on sentiment analysis of e-commerce reviews, insights for strategic improvement. We will walk you through our research, which leverage machine learning techniques to classify customer reviews and extract actionable insights for businesses. Before we begin, we would like to acknowledge the efforts of our team members, William Anchayadi and Patricia, and express our deepest gratitude to our supervisors, Dr. Insinyur Alexander Agung Santoso Gunawan and Jeffrey Junior Teja Sulaksana. Their guidance and expertise have been instrumental in the success of this project. Next, our research focuses on automating sentiment analysis to classify e-commerce reviews into positive, neutral, and negative categories. By analyzing eBay reviews, we tested several machine learning techniques, including TF-IDF with logistic regression, LSTM, fast text, and artifact. The findings reveal that while TF-IDF delivers high accuracy, it struggles with underrepresented data classes like negative reviews. On the other hand, deep learning models such as LSTM and pre-trained embeddings like Word2Vec and FastText excel in handling complex language and minority data. These results provide practical tools for businesses to improve customer satisfaction by addressing critical areas and highlighted in customer feedback. Next. Customer feedback is an essential resource for businesses in the e-commerce industry, offering insights into user satisfaction and areas needing improvement. Among all reviews, negative feedback is particularly valuable as it often highlights specific issues such as defective products, inaccurate description, or delivery delays. Addressing these concerns effectively can lead to significant improvement in customer retention and satisfaction. However, the manual analysis of reviews is labor-intensive and inefficient, given the sheer volume of feedback generated daily. To overcome this challenge, our study explores the automation of sentiment analysis using machine learning by classifying reviews into positive, neutral, and negative sentiments. Business can quickly identify trends and act on critical issues. Our research compares the effectiveness of traditional methods, deep learning models, and transformer-based approaches in processing e-commerce reviews. This comparison provides practical recommendation for using sentiment analysis tools to inform better decision-making. Sentiment analysis has evolved significantly over the years, employing a variety of classical and advanced techniques, such as naive Bayes and SVM, are computationally efficient and effective for basic text categorization. However, they fall short when dealing the human language, such as sarcasm or contextual shift. Deep learning, such as LSTM networks, provide a more robust solution by capturing sequential patterns in the text. Despite their strength, the LSTM models often face challenges in handling long-distance dependencies. Meanwhile, the models such as BERT have emerged as the gold standard in natural language processing. BERT's ability to capture bidirectional context makes it highly effective at analyzing complex language structures. However, research comparing these approaches, particularly in the context of e-commerce reviews, remains limited. Our study fills this gap by evaluating and comparing the performance of these methods to determine their effectiveness in extracting actionable insights. This research utilized a dataset of eBay reviews sourced from Kaggle, categorized into positive, neutral, and negative sentiments. The data was split into three subsets: 80% for training, 10% for validation, and 10% for testing. The performance of these models was evaluated using accuracy and F1 scores, focusing on how well each model handled underrepresented classes, such as negative reviews. And the goal was to determine the best performing approach to provide businesses with actionable insights. Next. The pre-processing phase was vital for ensuring data quality and model accuracy. Initially, noise such as punctuation, special characters, numbers, and URLs was removed to declutter the text. Text normalization was performed by converting all letters to lowercase, creating uniformity to the dataset. Next, tokenization broke the text into individual words or token for granular analysis. To further enhance efficiency, we applied stemming and lemmatization to reduce words to their root forms, minimizing redundancy in the dataset. For example, running and ran were reduced to run. Common stop words such as the, is, and an were removed, as they provided little value to the analysis. Finally, the clean text was factorized using TF-IDF to capture word importance and pre-train embeddings like word2vec and fast text to preserve semantic meaning. This pre-process step optimized the data for effective machine learning analysis. Next.
For the exploratory data analysis, we begin by exploring the dataset. A Sankey diagram helped us understand how customer feedback flows across categories like product issues, delivery problems, and feature satisfaction. Word clouds visualize frequent terms in different sentiment classes. For example, problem appeared prominently in negative reviews, while great dominated positive reviews. These visuals guided our understanding of customer priorities and areas for improvement. For the TF-IDF plus logistic regression model, it achieved 94% accuracy, and the F1 scores were 0.97 for positive, 0.60 for negative, and only 0.09 for neutral sentiments. It's efficient but struggles with minority classes like negative reviews. For LSTM, it achieved 93% accuracy and excelled at detecting negative sentiments with an F1 score of 0.56 and handled sequential patterns effectively. For word2vec and fast text, these pre-trained embeddings achieved an average F1 score of 91.5% and outperformed TF-IDF in semantic understanding, especially for complex and minority classes. Traditional models like TF-IDF are efficient but lack depth of complex sentiments. LSTM and pre-trained embeddings provide better semantic understanding and performance on underrepresented classes. The dataset was biased toward positive reviews, which is common in e-commerce. Resampling techniques can help improve performance on underrepresented classes like negative and neutral sentiments. These reviews often stem from mismatched descriptions, faulty items, or delivery issues. Businesses should focus on improving these areas to enhance customer satisfaction. By using sentiment analysis, sellers can align product descriptions with functionality, leading to higher customer satisfaction and better reviews. For the conclusion, the two best models are TF-IDF with logistic regression, which is efficient and handles frequent classes well, and also LSTM and pre-trained embeddings like word2vec and fast text excel in semantic understanding and perform better on complex sentiments. Negative feedback provides actionable insights for strategic improvement. Using these tools, businesses can improve customer satisfaction by addressing issues proactively. Thank you for your time and attention. It has been a pleasure to share this with you today. I hope the presentation was helpful and provided some useful insights.